Hey there, Mr. Weaver here. This is Topic 6, Lesson 1, Exponent Rules. After this lesson, you need to be able to use the rules or laws of exponents to create equivalent expressions. You'll know you're successful after this lesson if you can use the product rule, quotient rule, and power to a power rule, and you can understand negative and zero exponents. First, in order to understand the laws of the exponents that we're going to go through, you need to make sure you understand the parts of our exponents. So, an exponent has two parts. We have the base, which is the larger number. That tells you what is multiplied. And we have the exponent, which is the smaller number that's raised, and it tells you how many of the base get multiplied together. Or you might see like how many times the base is multiplied. So for example here we had 5 to the third power. This is 5 multiplied 3 times. So 3 5s are multiplied together. If we're dealing with numbers and it remains kind of small, and by small I mean like less than a million, then we can multiply it out. So 5 to the third power, or 5 times 5 times 5, is 125. Now that we know our parts of our exponents, let's look at some of the rules or laws of exponents. So the first one is the product rule. This says that when multiplying two numbers with the same base, you add the exponents. In all of these rules, the key is they need to be the same base. So here we have an example, a to the m times a to the n. They both have a base of a, so we can add the exponents. A to the m times a to the n is a to the m plus n. If we look at it with some numbers, 4 to the 7th power times 4 to the 2nd power would be 4 to the 9th power. The base stayed the same, and we added the exponents. 7 plus 2 is 9. The same would apply if we had a variable or if we had a negative exponent. So x to the negative 3 times x to the 8 equals x to the 5, because negative 3 plus 8 is 5. Again, the base did not change, just the exponent changes. Another rule is the power of a power rule. So essentially here, you have an exponent and then you're raising it to another exponent. When you do that, you multiply the two exponents together. So if we were writing it as a to the m, and then we take that and raise it to the n power, we would multiply m and n. Again, the base doesn't change. It's still a. Our exponent would now be m times n. So if we look with numbers, so 3 to the 8 to the 5th power is going to be 3 to the 8 times 5, which is 40. So our final would be 3 to the 40th power. Or if we look with variables, we could have x to the negative 2 raised to the negative 4. So our exponent raised to another exponent. Negative 2 to the negative 4. Negative 2 times negative 4 is positive 8. So that would become x to the 8th power. One thing with the power of a power rule, if there's more than one thing inside, the exponent outside the parentheses that you're raising it to, it gets reverse distributed essentially to every base that's inside. So here we had 4x squared to the third power. That outside third power needs to go to the 4 and to the x, because those are different bases. So 4 to the third power, and then x squared to the third power would be x to the 6th. And then because 4 to the third power is not very large, we could multiply it out and say that 64x to the 6th. So if you happen to see more than one thing inside parentheses, take the exponent outside of parentheses and distribute it to every part inside. Our third rule is called the quotient rule. This is the opposite of the product rule. So when dividing two numbers with the same base, subtract the exponents. So a to the m divided by a to the n is a to the m minus n. Same base, just subtract the exponents. So if we had 7 to the 5th divided by 7 to the 3rd, we would get 7 to the 2nd power, because 5 minus 3 is 2. Or you might see it written as a fraction. Fractions are division. So p to the 7 divided by p to the 9, I would subtract 7 minus 9 and get p to the negative 2 power. Two other things that you're going to see are negative exponents and exponents of 0. Let's start with negative exponents. A negative exponent is just the reciprocal of the same base but with a positive exponent. So if we had a to the negative n, we would take the reciprocal, which just moves it to the opposite side of the fraction, and it becomes the positive exponent. So a to the negative n is the same as 1 over a to the positive n. This can be super helpful, especially when we are simplifying expressions with exponents. We don't want our answer to have a negative exponent in it. So we can use the fact that it's a reciprocal and move it to the other side of the fraction. If we had x to the negative 2, that would be the same as 1 over x squared. Or if we had a negative exponent on the bottom of the fraction, such as 1 over 5 to the negative 4, we could take the reciprocal, which moves that to the top, and it becomes positive. So 1 over 5 to the negative 4 would be the same as 5 to the positive 4 over 1. And then 0 exponents, please just memorize this. Anything to the 0 power is 1. So if it has an exponent of 0, the answer is 1, or that part of the expression is 1. So a to the 0 is 1. X to the 0 is 1. 273,645 to the 0 power is 1. Doesn't matter how large or small it is. If it's to the 0 power, it is 1. When we're simplifying expressions with exponents, sometimes you might need more than one rule. Here you can see we have some expressions, one that I will go through and then one that you will do, where they look a lot more complicated. But if you look closely, the base is all the same. So in my example, 8 to the 4th power times 8 to the 3rd power to the 5th power divided by 8 to the negative 29 times 8 to the 2nd. All have a base of 8. So we can use our laws of exponents to simplify this out. Let's go through it. First here, I'm going to take that power to a power and simplify it out. So 8 to the 3rd to the 5th, power to a power, I need to multiply. So 3 times 5 is 15. So 8 to the 15 power. Then I can take everything else. Now I can simplify the top. 8 to the 4 times 8 to the 15. Here's our product rule. We would just add our exponents. So I would get 8 to the 19. And I can keep the bottom as it is for now. Now I'm going to simplify the bottom. Again, it's the product rule. 8 to the negative 29 times 8 to the 2. Add them together. 8 to the negative 27. And finally, I can use my quotient rule. So here I would need to subtract the exponents. Be careful, you are dealing with subtracting a negative. So 19 minus negative 27 is 8 to the 46. You could have also taken that 8 to the negative 27 on the bottom and wrote it as a positive number on the top, and you would end up with 8 to the 19 times 8 to the 27, where you're just adding them. And you end up with the same answer, 8 to the 46. If you were to use a calculator and multiply that out to see if it's worth writing out as a number, you would end up with around 3.48 with 41 zeros. Not worth writing it out. Just leave it as 8 to the 46. Now it's your turn. Pause the video and simplify your exponents to come up with a single base of 5 with its exponent. Let's check. You should have got 5 to the 6th power. If you start with a power to a power on the top, 4 times negative 2 is negative 8. And then negative 8 plus 21 is 13. On the bottom, you would have 3 plus 4 is 7. So 13 on the top, 7 on the bottom. Quotient rule, subtract 13 minus 7 is 6. Finally, what if you come across an instance where the bases are not the same? So remember, you cannot use the rules unless they have the same base. One thing you can do is sometimes you can change one base into an equivalent expression of the other base. Now, this doesn't always work, but occasionally it does. So if we have 8 to the 4th times 2 to the 5th, you might be tempted to just add the exponents and get 9, but 8 and 2 are not the same base. However, that base of 8 can be written as 2 to the 3rd power. 8 is 2 times 2 times 2. So if we were to change the 8 into 2 to the 3rd power, then I could take that, raise it to the 4th power, and I'd end up with 2 to the 12th. Now I can multiply that by 2 to the 5th, add the exponents, it would be equal to 2 to the 17th power. If you were to use a calculator and check and multiply out 8 to the 4th times 2 to the 5th, you would get the same answer as 2 to the 17th. So that's another way you can check to make sure you're doing stuff correct. Use a calculator, see if you get the same number at the end. In this lesson, we learned about solving problems with exponents. When we're doing that, there's a few laws or rules that can help us to simplify the expressions. However, when you're doing those, they have to be the same base. Once they're the same base, then we add our rules. If you are multiplying them, add the exponents. If it's a power to a power, multiply the exponents. If you're dividing the two things with the same base, subtract the exponents. If you see a negative exponent, especially in your answer, move it to the opposite side of the fraction and change the exponent to positive. Finally, we had 0 exponents. If you see an exponent of 0, that part of the expression is equal to 1. We also saw that if it's not the same base, you can't do anything to the exponents unless we manipulate it a little bit further by changing one base into the other. So, after this lesson, do you know how to use the product rule, quotient rule, and power of a power rule? And do you understand negative and 0 exponents and how to manipulate with them in our expressions? If you're not sure about these things, go back and look over the different rules, especially the examples on the sides that show what to do to deepen your understanding of this concept. And that's the end of lesson 1 on exponent rules.